Year 6, Lesson 5, Extensive Exercise, Question 2. A puzzle starts with 16 numbers placed in the grid as shown. On each move, you're allowed to swap any two numbers. The aim is to arrange for the total of the numbers in each row to be a multiple of 4. What is the smallest number of moves needed? So here we want to make sure that each row is divisible by 4. In order to understand this question, first let's look at the remainder of every single number when divided by 4 to see what we need to move. For example, 1 has a remainder of 1 when divided by 4. 17 also has a remainder of 1, 13 has 1, and 10 has a remainder of 2 this time. Now I'll go through this table and write down the remainder for each one. So, as we can see, in this table, most of the numbers have a remainder of 1 when divided by 4, but some of them have a remainder of 2. Now, in this question, we can move some numbers around. So how does that change the remainder of the row when divided by 4? Now, this uses the additive property of remainders, which tells us when we add numbers together, when we add two numbers together, for example, the remainder, when divided by that same divisor, will just be the sum of the two remainders. We do need to be careful that that remainder is always between 0 and 4, well, 1, 2, or 3, because if the remainder was 0, or the remainder was 4, or a multiple of 4, then of course that can be divided by 4. So, how can we move these numbers around? We could swap numbers that have a remainder of 1, but that will not change the remainder for each row when divided by 4, because these numbers have the same remainder. So we can only really change numbers that have a remainder of 1 and a remainder of 2. So how can we find rows that have a remainder of, or something divisible by 4? Well, we can see that there are 1, 2, 3, 4s. 4 2s, 4 numbers that have a remainder of 2. So the only combination for these numbers that have a remainder of 2 will be to put them in the same row. So therefore our remainder will be 2 plus 2 plus 2 plus 2, which gives us 8. So therefore the smallest number of moves, and there's lots of ways to do this, but we just need to make sure that they all fall in the same row. So we can use 1 move, 2 moves, so I'm here positioning each 2 in the bottom row, and then 3 moves in total. So there are 3 2s which do not fall in the bottom row. So the answer is going to be 3 moves.